Hello everyone. This video presents the solution to example 19 on rotated vessels. So here is the problem. The tube shown is rotated about axis AB. What angular speed is required to make the pressures at B and C equal? The pressure at C double that at B. And third, what is the minimum pressure in part 2 if the liquid in the tube is water? So this is the given figure. So since this is 45 degrees, this distance is also 0.6 meter. Then because A is open to the atmosphere, the vortex of the imaginary parabolic surface should coincide with this, and it rises parabolically outward to C. So since the head over B is always 0.6, for pressure at B and C to be equal, so the height at C should also be 0.6 to the parabolic surface, imaginary parabolic surface. So that's also 0.6. So substitute into the equation, 0.6 equals 0.000558 omega square 0.6 square. The radius is 0.6. So omega is equal to 54.61 revolutions per minute. Then for part 2, so that the pressure at C is double that at B, since the pressure head at B is always 0.6, so the pressure head at C should be 2 times 0.6 or 1.2 this time. So this should be the imaginary parabolic surface of zero pressure. So substitute 2 times 0.6 equals 0.000558 omega square 0.6 square. So the angular speed will be 77.23 revolutions per minute. Then what is the minimum pressure in the second part? So this part here, if the liquid in the tube is water, so the minimum pressure occurs somewhere along BC, but we have to locate it. So let's call that point with minimum pressure as P. Its distance from A horizontally is X, and we will call the distance to the point P to the imaginary parabolic surface of zero pressure as HP. Call this X, call this distance from horizontal line AC to that parabolic surface as Y. Since this is 45 degrees and this is 0.6 minus X, so 0.6 minus X, so this distance is also 0.6 minus X. So that HP is from the figure Y plus 0.6 minus X. And let's minimize H sub P for pressure at P to be minimum. So expressing Y in terms of X by squared property of parabola, Y as to X squared equals 1.2. This is 2 times 0.6 as to 0.6 square. So Y therefore is 10/3 of X squared. Substitute into HP. 10/3 X squared plus 0.6 minus X. Then finally, let's minimize HP by differentiating it, then equate to 0. So 20 over 3x minus 1 equals 0. Solving for x is equal to 0.15 meter. Then solve for HP minimum, 10/3 of 0.15 square into this formula here, plus 0.6 minus 0.15. So the minimum head over that point is 0.525, which is less than 0.6. So that's really minimum. So minimum pressure therefore is gamma of water times, because the pressure is 0, so gamma of water times 0.525. So minimum pressure that will develop is 5.15 kilopascals. So that's it for this problem.